Hey everyone, today just wanted to talk a little bit about what Dataflow is. So LabVIEW is a Dataflow language, and we're going to talk about what that means, why that differs a little bit from a lot of other programming languages, and how you can kind of leverage that. So I have a few examples here. This first example, we're just going to look at what is Dataflow and what exactly does that mean. So we have some really simple code in this VI. What this does is we just have an addition node here. So what it does is take two numbers and add them together, and then it outputs the result of that addition. So we have x, we have y, and it outputs x plus y. So pretty straightforward. Now, the way that Dataflow works is a node, so this addition here is what we're going to refer to as a node. It can't actually execute until all of its inputs are available. So this one specifically has two inputs, x and y. And then once both inputs are available at the node, it can execute, and then it will output whatever after it has finished executing. So this one has two nodes, right? So we have x and we have y, different functions, different VIs will have variable amounts of inputs, anywhere from having no inputs to having a lot of inputs. So it's all going to vary, but the basic concept applies regardless, in that it can't actually begin executing until all of the inputs are available. So if we're looking at how LabVIEW is going to execute this bit of code here, in order for the addition to execute, LabVIEW has to first read the value of this x control, which is right here on the front panel. So it's going to read that value. It also has to read the y value, which is right there. And then once that data becomes accessible to the addition node, it can execute and then output the value. Now, one thing to note is there is nothing controlling the data flow between reading the x control and reading the y control, right? There's no inputs into either of them. There's nothing controlling the order of what's read. So at this point, it's up to LabVIEW to decide what it's going to do. So you don't actually know whether it's going to read x first or read y first. Now, in this example, that doesn't really matter, right? Whether it reads x first or y first or read both at the same time, it doesn't really matter, right? But there are other applications, and we'll walk through some more complicated ones in just a sec, where that may matter more. So just be aware, these wires here are how we are controlling the flow of data, which in turn controls the execution of the software. So it's a little different than the typical control flow that you'll see in, a lot of different text-based programming languages, stuff like that. So, but yeah, that's the basic concept. What to remember is a node cannot execute until all of its inputs are available. And then if there is no explicit data flow created through wiring, it then becomes up to LabVIEW to decide when it's going to do what. So let's go look at another example. So here, and you don't need to worry too much about what exactly this is doing, but what this is doing is opening up a file, writing some data to it, and then closing the file. And now, so our basic order of operations, right, is we want to open the file, input the text, close the file. Now, the way that this is set up, we're going to right, our write to text file has a wire coming out of our open text file. So this open file node has to execute before this, and this wire also runs to the close file, meaning that the open has to execute before the close. But the way I have this wire here kind of branched and running to the close, there's not actually data flow set up between this write to text file and the close file, meaning that we don't actually know the order of operation between this and this. We know that the open function is always going to happen first, because both of these other nodes are dependent on the open. But we can't actually know whether the close will happen first or the write. Now, if the close were to happen before the write, obviously that's going to be problematic, because then we're going to get an error when we try to write this data to the file. So that becomes a problem. So the proper way to do that would be something more like this, where that wire runs through. So now we've created sequential data flow here, right? So the open has to happen first. The write has to happen next. And because the wire is coming out of that write, the close cannot happen until the write has finished executing. So this way we're controlling that sequential kind of order of operations through the data flow through these wires. And now let's go look at one more example. So here we have similar example, right? We have just a file. We're going to open. We're going to write some data to it. We're going to close that file. Now we also have some other components here. So we have this node here, prompt user for input. So what that's going to do is just pop up a dialog box and basically ask the user, what do they want to write? So we're going to take whatever they type in, and that's going to be written to a text file. Now we also have this other node here, so display message to user is going to pop up a dialog that just displays a message. So the message we're going to show is file saved. The way this is currently set up, we have two nodes that could execute first, right? At the start of this, we have this open file, and then we also have this prompt user for input, right? There's no data flow between these two because there's no wires running between them. So we really have no way to determine what will execute first, right? It could be the open file, it could be the dialog, and realistically, it probably doesn't really matter which one it is. And then from there, this write to text file is dependent on a couple of things, right? So it's depending on this file reference coming from the open, the error wire coming out of the open. And you don't need to know about what those wires are quite yet. We'll talk about that. But yeah, it's dependent on some of the outputs of this open, but it's also dependent on the output of this prompt user for input, meaning that this node cannot execute until both this and this have finished executing, at which point then we can go to this close. Now, intentionally, this display message to user over here is also not set up correctly, right? So there is no wires running into this beyond just this file saved message, so that we're not actually controlling data flow here, right? We have no way of knowing when this display message to user is actually going to pop up. So it's possible this could actually pop up before your prompt user for input or the open file, right? So we have no way of knowing. It's up to LabVIEW to decide, because we haven't actually defined the data flow. It's up to LabVIEW as it's compiling this code to determine that order of operations. Obviously that can be problematic, right? You want the user to know once the file has been saved that it was saved properly. And right now you don't have a way. And this could, like I said, pop up before you even ask the user what they want. So there's different ways we can enforce this data flow. But again, the very simplest way is by running wires from one thing to another. That is the easiest way. So if we wanted this to occur after we've closed the file, which will save the results, I could run that error wire out into there. So now we've created a data flow where one of these two nodes will execute first. The write will happen, the close will happen, and then we'll get a dialog that lets you confirm that the file has been saved. So it's really important that as you are starting programming that you're considering the data flow of things, considering how the order of operations is going to occur based off how you've set things up. Make sure that you have, proper data flow to make things happen in the way that you're intending them to happen in your head. And this is a foundational concept to programming in LabVIEW. Obviously, in LabVIEW, we're using wires to pass data between different functions, between different nodes. And that's very different than like text-based programming, where we might have various functions that aren't directly connected, right? That can be called by name, and we may have different variables used throughout the application that we can call, and we don't have to directly route, data from one function to another. They can simply call like a variable or something like that, and any function can basically call whatever function. So, and you basically get like a top-down flow, right? If you have, a function that's maybe like 30 lines of code, right? Well, you're starting at the top of that function and working your way down. Now, there may be loops and stuff in there that cause it to, iterate, but the basic concept is top down. Here, we're going inputs to outputs. So all the inputs become available, a node executes, it outputs data, and that goes on and on and on throughout your application. So that is the basics of data flow programming in LabVIEW.
Canon Controls is your gateway to mastering LabVIEW. Dive into programming for data acquisition, industrial communications, and manufacturing automation. Explore how to enhance your projects with cybersecurity best practices. Join the journey to elevate your skills and secure your systems with every episode.